Hi everyone and welcome! Today we have a special guest here. We have Masha from Ukraine, from Kyiv, that she's gonna talk about systems, biomedicine, epigenetics, metabolism, a lot of cool stuff that you might be interested in. Hi Masha, very nice to have you here. Thank you very much for accepting my invitation.
Hi guys, and hi Melanie, and thank you very much for inviting me.
So first thing I want to ask is, how did you choose the career that you did in Ukraine? Also, where did you study? Tell us a bit about the story.
Hi guys, my name is Mariia, and I came from Ukraine, and my home city is Kyiv, which is the capital of Ukraine. I studied general biology in the Kyiv National University of Ukraine. To be fair, it was a great experience. I never had doubts regarding this field, this specific direction. My first big aim, my first big dream was to study medicine, and I did quite a lot to do it, but unfortunately our medical education in Ukraine is not that perfect, and then I decided to switch a bit and to choose biology because first of all my main goal was to do something that would help people. Biology is the case, in my opinion. And as I already told, I studied general biology, but then my main direction was cell biology. I like it a lot, but unfortunately the main problem in Ukrainian education is that we cannot practice what we just studied. However, the theoretical education is quite good, considering that our institutes don't have a lot of equipment and a lot of specialized people who are specialized in a particular field. That's a problem. And young scientists like me are trying to go abroad and study and acquire practical knowledge and to do as much as possible to study and to do science. The bachelor's is for 4 years, and then after you're done with bachelor studying, you do your bachelor's thesis, and your department in the university is helping you to choose your topic, your institutions, governmental institution. But it doesn't matter that you will find what you want there because of limitants, because of as I already told, because it might be a problem to finance your thesis.
Yes, I understand these troubles because in my country it's a similar situation. Not every branch of biology is there. There's not much money for projects, so there's some limitations. And what happened after your bachelor's then? Because now you are in Germany doing a master's. Tell us a bit about this transition. What did you choose to specialize in?
2 years ago, I got an amazing opportunity, amazing chance that I'm really grateful for. To be a part of MGen Scholars Program. It's an internship program that helps young scientists, young bachelor scientists throughout the world to conduct internship in a lab that might be in Karolinska Institute or in Nuesch University or in University of Pasteur in France, and there are some other universities that are members of this MGen Scholar Program. I was doing internship in Karolinska Institute in Sweden, and that was an amazing period of my life, and there I studied what science is and what people in science can do. Particularly it was important for me because their science is really applied science, and the biomedical research is the main emphasis there. And there I first have seen what neuroscience is because I was working in the field of molecular neuroscience, and it kind of boosted my motivation. And then I realized there's time to show world what I can do, what I can do in science, and in particular in neuroscience. And that's why I came up with the idea to apply for master program abroad. And yeah, then I applied and I got accepted. That was very nice to be accepted and to be part of this program, of this scientific life here. And because you can study a lot and you can see how neuroscience works.
Yeah, that's really cool, congratulations. And can you tell us, inside neuroscience then, which topics are your favorites, or what did you explore during your masters?
Considering that neuroscience is not just the methodology, it's a field, it's a big field that includes a lot of directions. And since my love towards cellular biology, molecular biology is extremely big, I decided to combine these fields and to, and in particular, what my biggest interest is in neurodevelopmental diseases. And considering that we had chance to conduct 3 lab rotations, two of them were in the field of systems biology. So I was not just concentrated on specific protein or specific receptor. I had a chance to see the network of molecules. As in case of first lab rotation, we were looking at metabolomics and metabolomic profile of microglial cells. Interestingly, metabolomics is the quite young field that is developing continuously nowadays, and what basically people are doing within this field is trying to, since metabolites are the ending products after all biochemical circuits within cell, that's important to see what we got at the end, which metabolites are there at the end, and which metabolites are there during normal function, or which metabolites are there during pathology, and how the cell reacts inside. And that would be interesting to continue working on. And then I decided that it would be also a great chance to see how genes work. Currently, I'm working on epitranscriptomic profile of neurons with tau mutations. And with epitranscriptomics, I mean the studying of modifications of RNA. There are DNA that can be transcribed, and as it's already established, then RNA might be modified after transcription. And it seems to be a very important process, not only during normal function of neurons, but also during the pathology like Alzheimer's disease or in general in dementia. That's quite exciting because tau is the protein that can aggregate during Alzheimer's disease. It will be interesting to look at the epitranscriptomic profile within this pathology, and probably we will understand the mechanisms of this disease, and something like this might be possible in the future.
Cool, it's very interesting. I actually also like this field, so for me it's like the most interesting. I also wanted to ask you, so I mean, you already explained it very nicely, but maybe because we have people that are not exactly from these fields, Can you say some conclusion or words about the importance then to having scientists working on this, developing these fields, that these fields are invested on?
They feel like metabolomics can be applied not only to treat the disease, but also to diagnose them, to catch them at the very beginning, for example, of neuropediatric diseases that are quite rare but very severe.
Yes, I totally agree. These areas are very important. The potential is huge. A lot of diseases, neurodegenerative diseases, neurodevelopmental, you name it. And then, so coming to an end, I wanted to ask you if you have a particular tip for students that are where you were at one point in Kyiv, studying, wanting to pursue these areas. I don't know, you have any comments for them?
The main thing that I would recommend to young scientists is to try and not to be afraid of anything. And in particular, I would strongly recommend to apply for various internships abroad to see the truth of science, of scientific work, of scientific community, and then you may decide to apply for master thesis, for example, or for extended internship somewhere else abroad. Moreover, such internships give you a very great opportunity. For example, during the interview, when you are applying for a master thesis, you can say, like, I was a part of this big internship that was that really boosted my motivation, my passion, and the people that are accepting you, they would appreciate it. They would appreciate your efforts that you made beforehand.
Yes, those are very nice tips. Thank you. I agree. And thank you very much for giving your time to be here. I really appreciate it.
And thank you very much, guys, for watching this, and thank you very much for your efforts that you're making every day to reach your dream, and good luck with all your ideas.
Aw, that's so sweet. Yeah, thank you for watching. Have a nice day and see you in the next video. Bye bye.